Yeah, one of our role models is Renzo Piano. Thought it's an amazing quote about design and what it's about. Designing is a journey in a way. You set off to find out, to learn. You accept the unexpected. If you get scared and immediately seek refuge in the warm and welcoming lair of the already seen, already done, it's no journey. But if you have a taste for adventure, you don't hide, you go on. Each project is a new start, and you are in an unexplored territory. You are the Robinson Crusoe of modern times. Renzo Piano. Look, life is ironical. You know, I really wanted to be a painter, and my ex-brother-in-law convinced me to become an architect. I now paint, but I have a concern for the city, and being a busy architect, I believe that that's where our interest should be. You know, our cities are of big concern. A lot of people live outside our cities. The densities of our cities are extremely low. A lot of poor people are traveling annually and daily on a massive scale. Our concern for cities had also brought us to go and study urban design. Pedro did it at WITS and I did it at UCT. And we've got the philosophy that all buildings, in fact, are little cities. And the city is a big house or a home. And this notion comes way back from a man called Alberti, who in 1452 actually wrote guidelines about what the city should be about. He had guidelines for public buildings, guidelines for houses, townhouses, country houses, etc. That was 1452. It's ironical now that people make suburban houses subscribing to stylistic styles. I think the one thing that Alberti said, he called the house La Piccola Città, you know, which in a sense talks about the relationship between the house plugged into the city and the city plugged in as part of the collection of houses. In our work, we've, over the 10 years that Peter and I worked together, we had all kinds of projects coming our way. The one on the left at the top is the Clipdown Soweto competition, which Studio Mass, Piers Swanepoel's firm, sitting here, won. And what we did there, we had this notion that we would capture the footprints of where the people walked. We could see that on an aerial photograph and make that as a monument of light. And then create an urban world around that with a public market, public institution, and a place where you could actually have art exhibitions, places of slaughter, etc. So these marks in the landscape then became sluits that you would put glass over, and they would actually have objects put in them, poetry, artifacts, reliquary, and so forth. So at night it becomes this monument of light, celebrating where people did the Freedom Charter. The bottom slide indicates work that I did with Roelof Uitenboogaard when we did the Olympic Village in Cape Town, 2004 bid. It was done in 1996. And it indicates a part of the city called the Culemborg, which is the big shunting yards lying out here. Unused, the idea is to convert that into public and private development. And at the time, the idea was to develop a sports center over the railway line. So what you see in this part here is a sports center developed over the railway line in a big public space. And this would have been the Olympic Village, where about 24,000 people would be living. On the top right, you see the Melrose Arts Project. It's flanking OMM, Andrew and Janina's project on the left, where the Moyo restaurant is in Johannesburg. And our building was part of that pattern of setting the urban spaces around it, making urban space. So in a sense, what we'd like to believe is that our buildings should make urban space wherever they are. The bottom right slide is a little creche we did in Kabodi Street in Brown's Farm in the Cape Flats, where we won a local competition Joe Nero won the other jointly. And we put together 2 of these creches, of which we thought they would become prototypical creches. And they double up as spaces where public adults could use them at night, and during the day they serve as creches. What our work indicates is an attention to detail. The top left you see shutters done on a farm. And we also believe in the 5th elevation, especially if a building is exposed to views. You'll see it later on the development of the BP building. At the bottom left you see the Unicity project. The chamber and the courtyards really reflecting this sense of public space, with courtyards serving almost like public squares within the whole. This was a building that we converted, which was done in the 70s, and we put a light steel frame structure on top in order to create new accommodation and a chamber. On the top right you see a house in Bantry Bay overlooking the Atlantic Ocean. Sorry, I just want to get some water. The bottom slide indicates a farm, the farm that I showed you before, where the notions of Cape architecture in a modern idiom expressed. The focus again being on the buildings making public space. Okay, top left you see the creche, the way in which a little tower announces the entrance, and a seat where the children could wait for their mothers after work. This is quite an interesting community street, and the people love it who live there. On the right-hand side at the top you see the Birkenhead Brewery that we did, much earlier work that we undertook in Stanford. And the brewery's kettles are actually exposed on the inside of the building. So that you see it, you feel part of the brewing process. What they've done subsequently, though, they've changed this building, which makes one believe that if you finish architecture, you must take your photographs and run sometimes. The bottom left is a building we did in Hermanus, in Southwinds, called Southwinds. It's really a retreat, and it's based also on the traditional architecture of the Cape, with a roof that's cut loose from its structure, heavy, thick walls with small openings, and we branded this Corp Cape, referring to Le Corbusier in Cape Dutch architecture. The bottom left is the Union House building, which is down the road from us, where we really just had to apply an urban screen to protect from the sun and a new fire escape and balconies. Here you see the Unicity project, which you've seen from the top. It's a new chamber. It's been controversial in the sense that people have asked what the flying saucer is on the top. You may see it in the Telkom ad on TV. People have called it a basket for politicians or crooked like bananas, They've also called it other things, Christmas trees, etc. But what this did, in our belief, it is a new icon for the transformation of the Cape Unicity. And the building, in a sense, reflects the transparency of the new democracy. So from the outside of the chamber, you can look into it. Those walls of the chamber are glazed. At night, this cone lit up to indicate the weather conditions in the Cape. And it changed from colors from green to yellow to red in order to indicate wind, rain, and the like. At the top right is a house we did in Camps Bay. It was quite widely published. It was done for an Italian guy and a guy from England, and they wanted a combination of really Tuscan and the London pad. And so this is our interpretation of Tuscan. We did bus stops for UCT, for the students. They also become prototypical, so they're built all over the campus now. That's a gate that we did at the farm at Nivesion at Simondium. A new house we're doing for an American client at the bottom left. And a little urban infill project that Philippe did, a shop in Short Market Street, Cape Town. In our architecture, we try and blend in landscape with building in as much as we can. And I think this painting tries to reflect that. The idea of seasons over time. Right, what I included here is a project that we did for the University of Pretoria, the law faculty building there. We partook in a competition of which OMM was part, and Andrew and Janina actually had a wonderful scheme, and I think they still want to build somewhere else. This was our competition entry, and we again had the notion that the street would be inside the building and the public squares would be inside the building. So the building is really a collection of urban spaces, and that we would react to the existing open space by creating an urban space, and that the building really makes that urban space. The linear building that you see in the front is the library of the law faculty, and at night you see the activity of the students inside there. On the right at the top you can see the auditorium. The idea was to take this axis of trees through the building and bring that in as the most public entrance. We believe in the strength of diagrams, the notions of expressing the spatial things that we'd like to make firstly before we design the building. And that's the plan. The green quads you can see are the courtyards where students mingle and sit, and those are the lecture facilities. In the front, the linear building is the Oliver Tambo Library, and in a sense you see through these, through the library right into the courtyard, and at night they lit up so that you actually see the activity of the students as well as the courtyards internally. What we do in our design process, we work with different techniques. The one thing that we do is we build models of everything that we do. We build them at various scales, start with them off at smaller scales of 1 and 500. You'll see later when we show the BP building. And this is an early model of the law faculty building. It also makes us understand how to resolve details, etc. And also using three-dimensional modeling, the way you can see through the library into the courtyards to make the client understand what we'd like to achieve. Now this is the law faculty building. On the right you see the Center for Human Rights, which has got a good international reputation. And then the entrance, which is the main focus, and the library to the left. A night shot of that. In most of these bureaucratic institutions, the offices actually become quite boring and repetitive. And Eben van den Berg, who's here today, took me seriously when I said, couldn't we throw these windows around a bit? And he investigated ways in which we actually found a way in which to get each of these offices to have different looking windows. So although the offices are quite standard, each window individually looks different and therefore gives the office a different spatial quality. And then we've got these sort of pop-out balconies, on which people, smokers' balconies that people could use. They are made in steel, and also the fire escapes. In our architecture, we try, in everything that we do, express the notions of heavy and light, the earth and the sky. And in many ways, that's expressed in many different ways in projects. This is just a plaster and painted building, and the expansion joints were actually made in such a way that they coincided with windows and the like, and very carefully worked out by the team. Also the sills were very crisply made. inside of the library. The library works on 3 levels, and it's linked with a public walkway that could take you back to both the lecturers who are on the upper levels and the lower levels where the students are. So it's really like a little city within the campus. Another good quote, I think, on design, Giancarlo De Carlo, who died recently. Method and experimental curiosity, rigor and imagination, coherence and chance, rationality and irrationality are not irreconcilable opposites. They are poles of that oscillating dialectical reality which is the essence of life. And this painting, in a sense, reflecting the urban world, also reflecting people, I think. People read different things in it. I made it over Christmas, and I titled it Father Christmas Was Here. I'm going to show you the BP competition first. I think people might have seen it, but it's good for people who haven't to see the process that we've undertaken to firstly win the BP competition, and then secondly to implement it. This is an elevational sketch. When we presented to BP, we said we're not presenting a fixed concept, a fixed design, but we're basically doing a framework for design, a way in which they can interpret within the framework which they want. This is the site. It's actually next to the GSB, the old jail, on the V&A waterfront on Portswood Ridge. And it's a greenfield site with old Victorian villas sitting at the back of it. And it's to the entrance to the waterfront off the Western Boulevard. That's the urban setting of it. There's nice views onto the mountain and onto the marina. And what we reacted to firstly from an urban point of view is the fact that there's this orthogonal pattern of Portswood Ridge, which we wanted to respect in a way. And we reacted then to that straight line, which you can see in brown, which we believed should become the high street of the corporate offices. And then there was another design line that came through to the basin, which we had ambitious thoughts for, but which didn't materialize in the end, because the V&A had a court case with the city to prevent people from really using the basin for public use, which we were unaware of. So it was the idea of the Cartas de Camanas, the way in which the crossroads meet, and that the building really then sits in the forest, and it becomes a sort of a finger of built fabric into the finger of the forest. And that's just a diagram that Pedro did, that red line indicating the reaction to the pedestrian link. And we had the idea of a public institution, the circle in the front, that would face Dock Road. Now this diagram was after a lot of deliberation, after a lot of thinking where we should orientate this, because in a sense the Cape Town grid is at 45 degrees with north. So it sits, and Portswood Ridge follows that orthogonal grid. And therefore the building, in which way it would be orientated if it responds to Portswood Ridge, would have to be swung at 45 degrees, and we felt that it was more important to stick with the orthogonal patterning of Portswood Ridge. So we came up with the idea of just making the building quite simple. 5 fingers that meets the forest, an idea of a big pergola that would float over and give shade. So that in a sense, when you sit in the building, you almost feel like you're sitting in a forest. And in the white, you see the public street that we envisaged here, and that these little things would become the meeting rooms of BP, and that this would be a public community institution at that point, also sitting in a forest. We investigated things conceptually also on section, the idea of the forest cooling the building. The pergola would actually, as I said, shade the whole space, and it becomes a dynamic skin. We built a little conceptual model, a small-scale model, just to indicate how the building would ventilate and and so forth. And we had these huge skylights which would allow light in, but would also serve then as heat extractions. The way in which the elevations were done, sketch that Pedro made at the top there, and then developing them into very rationally thought out elevations. You could see in the thin line stripes the gallery, the high street, and then the little pop-out building facades then become the stucco elements that represent these fingers. And then the final model, we learned from Dominique Perrault that you light these models up, and they become very seductive. They almost look real. Now those facades really have a symmetry about it, but also asymmetry. And we often do that in our architecture. We believe in this thing of moving things, actually the energy of things being in the asymmetry. Now, at the early times we were still learning. We had Eric Noir on board from Green by Design, worked from Johannesburg, who's really been studying environmental architecture, and he gave us advice. We came with all these ideas, and he said, yeah, you can do this, you can do that, and so on. Of course, in the end, we learned later that it's all not quite practical. At the time, we thought we could use the southeaster to also have, use that as a cooling effect, use the northwester over the forest of trees to cool down over the roof of the building. Because buildings mainly build up heat because of all the machines, all the energy of the people. You've got to remove heat from buildings mostly. The other thing about South Africa, different to Europe, is that you want to keep the sun out of our buildings. In Europe, I think double glazing and the technologies they can afford there, they merely want the sun. The roof served as a dynamic skin in the sense of allowing both the sun to come in diurnally, in the red indicating the solar panels that one would get, collecting rainwater off the roof, helping with the cooling effect, and then we had this notion of photovoltaic cells, which BP made. BP France make these photovoltaic cells, and they were applied to the building later. Now, the idea of summer and winter when you need the sun, you could actually heat your facade, as you see in red there. And then now this big pergola lattice work to get the sunlight to come in. And then daylight would come through these skylights. We also looked at water cooling, that you use the basin to cool. And we looked at rock storage. The problem with rock storage, though, is that Cape Town has a composite climate, and it turned out to not be cost efficient to try and do that. It would probably be working better in a place like the Highveld or the Karoo. Yeah, so the environmental concept was to capture winter sun, to cool the building down through evaporative cooling through the courtyards with water cooling, etc. That was the early ideas. And we reacted in a sense to Ove Arab's brief. Adrian Campbell, who's a Scottish Londoner, who lived in South Africa and developed the red brief for BP. The section there is showing you the idea of that public space in the front, place where we thought people could communicate, invent, dialogue, talk about green design, what it's all about. We had notions of a little turbine at the end there, just as a little thing that could also generate energy and reflect the image of the green design. We did these models. The small model was at the urban level, indicating what the building would look like. And you could see the public street. And in the middle there, you could see a linear line that runs through it, which really was, in our view, what we would have liked to achieve, so that this building would actually then be linked to the water edge by getting a terraced garden that would come down to the water front. So we were taking a bit of urban design license here and designing the bigger scheme of things. Another photograph of that, you actually look down that tunnel, which will be like a ramblas, so that the urban buildings then create the facades, and there was the idea of this island there's a new hotel that's going to come across that island now that Sol Kersner is going to build. A one and only. It's going to be built in some kind of pseudo style, I believe. Yes, from the other side you see the basin and the BP building quietly sitting there. And that's the plan. We had narrow footprints where we had about floor plates of about 12 to 15 meters in our investigations. And we believed that we could cross-ventilate these buildings and that the facades would actually be made in glass. Because you're sitting under this roof, there's no problem with direct sun gain. And when you need it in winter, it's actually there. And that's a cross-section of it. At the time, it was a 4-story building. Because we also, at the time, the V&A also wanted to have some offices within the complex. And we had the idea that BP would be in 4 of these. And one of them would be the tenants that they would get in the future. And you could see the step garden in the middle coming down. And this high street would actually then come through and over, similar to the convention center here linking to the Arabella. And at the bottom right, you could see the section through. It's actually quite a narrow footprint. I must say, during the process of the real project, we doubted the fat footprint that we were given to make a corporate head office, because that's how things changed. People wanted a more consolidated, big plan. And then one day somebody came with a magazine where Richard Rogers also did a very big, fat building. And we realized then it could be quite possible if we put the street inside, but we'll show you that later. One of my sketches indicating that street, and Pedro used to explain them, that we had glass columns, but it's just the way I draw. Seeing through the space, looking into those courtyards, the high street, you see the public space, a sunken courtyard at the back there. And then that sunken space with those, the way in which we saw it is this could have been an auditorium where people could come for either research or there could be concerts out there. And it creates a new public entity at that edge of the waterfront where there's not really much happening. A lot of offices, and then the GSB, which has a hotel attached to. So it will give it another public amenity, taking it a little bit away and making the waterfront a little bit more mixed use. And that's the bigger model that we built. Those chimneys in the Great Street, we had huge chimneys which were on top of the lift shafts. And then you had the smaller ones over the pergola roof. Facades in the front. And the street then really covered by that pergola. And that's the model as you see it. How it came out finally. And we were required to all build the model at the same scale, scale 1 and 200, and they gave us this cast thing that we just had to plonk our model in. It was quite good to see all the different architectural responses. Right. Now in a sense, what I believe in the city to be the most important is really not only the footprint, but also the urban wall. This painting in a sense represents the urban wall, the transition between countryside and city. And in the architectural review, they wrote this piece which said the building is modest, larger than loud, palette of materials and details restricted, direct and intelligible. What we realized through the process, and when we doubted ourselves, we had huge arguments with the engineers, we doubted the engineers, we doubted the process, the footprint and all of that. And then one day we realized that it's all about orientation, all about how things are orientated in buildings when you design them in this way. And it's basically the first lesson you should learn in first year, is that orientation and keeping the sun away from facades are actually of the utmost importance if you want a building that works well environmentally inside. So we actually stuck with the orthogonal pattern of Portswood Ridge. We inherited, in a sense, a bigger footprint. And we decided then that the facades become hugely important. Not only the facades exposed to the building vertically, but also horizontally. And we had these lanterns then expressed in such a way that they are things that bring light in, but don't allow sun to come in. So that gave us another interesting challenge. Now this is what the building looked like. It reflects, I think, in a sense, the engineering of the whole process of the building, and I'll take you through all of that in detail. So in a sense, it's a very much an engineered building, and I've asked the engineers also express how they feel about the building and what we've achieved. So you see these lanterns on the top and those photovoltaic banks that sit there. The facade expresses, in a sense, the ventilation of the building. And you have these light shelves that we will explain. And the entrance canopy also has photovoltaic cells. So in a sense, all the energy values of the building are reflected. We built a big working model. Rafik Conrad, who worked with us, did this. And everybody just cut this model up and reinvented it and solved details. And we often do that. Building big models is a way of solving details for us. They're not necessarily beautiful models, but they're working pieces. The envelope of the building in cold weather, when you have the rain, and in hot weather, the extreme conditions being -5 or 32 degrees outside. The building is then insulated well. It's a concrete structure. There's double glazing on facades where we need it, where it's exposed to the weather, to the sun mostly. And the shading of the deep-set facades help to shade the building efficiently. The atrium lanterns serve both the function of allowing southern light in, so the trees could actually get light. They keep direct sunlight out to prevent heat gain. And they serve as exhaust fumes to take out warm and stale air. And they also serve as fire. At the time of a fire, there will be a fuse that releases the material to break open and the smoke to extract. And it also serves then as the fifth elevation, also reflecting in a sense the roofscape which is seen from Greenpoint, which looks right down onto it. We built a little model of these lanterns. I mean, Jan Wassenaar is also here. Took me seriously when I made a little sketch, made a model which then everybody got excited about. We built it a few times, and then the engineers helped us to orientate it correctly. We firstly wanted orthogonal with the building atriums. Eventually it developed into a diagonal placing because of the diagonal grid. So these skylights are designed in such a way then allowing light in, keeping direct sunlight out to the west and the north, and taking out the exhaust fumes and the fire, as I've said before. On the day lighting, these light shelves serve the function of low sun angles in winter, high sun angles in summer. Daylight penetration coming through, reflecting off the ceiling set back so that you get daylight penetration into the building off the reflection. And then the shading of those daylights light shelves help to shade the facades in summer, but allow heating in winter when you need heat radiation off because of the low sun angles. Of course, the lanterns, as I said, allow daylight in. And then the lights in the building are dimmable lights, which works with the diurnal cycle. They are dimmable, so that they give adequate light levels throughout the day by using the light shelves that give light penetration into the building, then saving on energy. So as the sun comes around the building, these dimmable lights change. On the roof are photovoltaic cells and the domestic hot water, which for all the hot water production of the building. Photovoltaic panels over the roof, you'll see them now, contributing to 10%, which is put into the grid. Climatic control, cold weather, in extreme conditions, you don't want more than 20% fresh air intake. But you don't want to make the building colder. And the supply air is then, that comes into an air handling unit, supply air coming back into the building. The heating elements at the diffusers giving heating to the office spaces. And then the return air, 80% coming back. And then you have a pressure discharge through these whirlybird elements where the stale air gets out. In hot weather conditions, you have the same situation, 20% fresh air coming in. Supply air, return air 80%. Of course, you get pressure discharge of warm air. This works also on a diurnal cycle, so it's not only seasonal, because in summer you may get cool days in the mornings, so that air conditioning system would actually come in and work on a 20% cycle if it's cold outside. And as the day progresses and things warm up, it gets heated and goes on to the 100% cycle. The fresh air comes into the edges of the building that we called bookends. They were treated very solidly because we didn't want on the north and west orientation to have too much sun gain. Return air goes into those hidden areas which sit on the insides of the facades because you don't want heat gains in the coolth of the building. And the supply air comes inside next to the fire escapes. You can see the atriums of the building there, and those are over which those lanterns are structured. So in intermediate weather, 100% intake, no return air, and that's during the bulk of the time. They also purge the building. So the building gets purged in the early mornings of the day, where the building gets purged with fresh air, and it's therefore got a very pleasant feel about it when you enter it, fresh air feel. And that's the way in which the discharge takes place. So in a sense, the air supply is mechanically driven. We had to do that to achieve the benchmark set by Ove Arup. But the air discharge and exhaust is passively driven. And that's what is reflected by these whirlybirds and these thermal chimneys. The chilling plant, in a sense, is like a traditional air conditioning unit plant with a meter box with variable flows that controls fresh air and return air in those cycles. So hot, cold weather, that's the section, how it works. The diffuser bringing in either heating or cold on the 20-80% cycle. Return air 80% going back into the basement. Pressure discharge at the top. Fresh air cycle 100%. You have supply air, exhaust air coming out, no return air. And the basement works with natural ventilation. Right, the water is captured in a big tank in the basement, grey water. It's about 1,350 cubic meters. It collects 4,000 square meters of the roof, 1,100 of hard landscaping, and also the grey water off the air conditioning system, which is about a third of the usage. And the building usage also collecting rainwater into that tank, 30% of the use. Okay. The building facades, in a sense, reflecting the engineering, you could see those light shelves at the top, chimneys expressing. Skylights, photovoltaic cells on the roof. The photovoltaic cells. See the skylights, the way they're designed. They've also got these fins on in order to prevent the direct 12 o'clock sun from entering them. So they're designed in such a way with special glass to prevent sun as the sun moves around the facades from getting into the building, but still getting light in. The timber that we used is local. It's from Zimbabwe, rose gum. And the trees would hopefully grow. Stairs, also rose gum stairs, steel structure supporting that. Skylights, this main stair going up to the roof. The Wild Bean, which is the little canteen, which is on the one edge of the building. This is winter sun coming in. Skylights at night. They're quite beautiful objects in themselves. Right, and these are quotes from the engineers. You know, I think Eric Noir felt that the building has diffused the stigma that all these buildings should look like a dog's breakfast, or they should be residential. Andrew Aiken believed that it's very important that the vast energy resources wastage that you get on building sites and building environment has been addressed with this building. You know, we have waste. The waste was actually ordered on site and taken away in specific packages. Patrick Costello believes that we used existing technologies, you know, to be quite innovative in resolving things. And Rob McNamara believed that from a green energy efficiency, the building, with its extensive photovoltaic array, providing approximately 50 kilowatts of electrical energy, has really gone a long way to saving electrical power. I just want to take you through what I really believe sustainable things should be about. A quote from Charles Correa, a painting really reflecting these squatter villages that we pass by so quickly on the freeway, the energy of that movement. Human cerebellum, the patterns of things, the understanding of that all things are made in patterns, even in our making. Informal settlements. When we did the Into Housing project, we looked at Caesar at Evora and the way in which he structured his facades. And we believe that the urban wall and the way in which they made it in the Boerkaap and they made it in District 6 and so on, the way in which the street interface works is of the utmost importance, the lessons of Alvaro Caesar. And we designed these tiny little houses that are about 30 square meters, which we tried to make built for 27,000 rand, but they cost over 40,000, which refutes this idea that the city has to be built at once. I believe it's got to be done incrementally. And then finally, the idea of the Greenpoint Stadium, the idea of an arena in the city, and the way in which you can structure it to create urbanity. Thank you. That's all.